This is the third block of topic 23. In this lesson, we're going to be investigating some plane sections and cross sections of three-dimensional objects. So we've talked about this before, that these sections are just slices of a solid that create a two-dimensional figure to look at. And so when we are cutting parallel to the base, it's called a cross section, and when we do any other slicing, it's called a plane section. So before we get started on the lesson, it's really helpful to visualize these slices. So it tells you on your notes here where you need to be in Agile Mind. So remember, to access the curriculum, you're going to russellville.agilemind.com, no www, and Agile does not have a D in it. So russellville.agilemind.com, and your username is your first name, last name, and then the last two numbers of your graduation year, the year you're graduating. But you don't use dots like you do in your typical login on your computer. So it's just first name, last name, graduation year, no dots, and then your RSD password. So once you're on Agile Mind, you will go to geometry, of course, topic 23, exploring, and the section we're in is plane and cross sections of solids, and you'll go to page 1. And so this is what your animation will look like, and so I'll just kind of get you started on here. You're going to select a target shape. This is what you want your cross section to look like, and there's 7 different ones that it wants you to get. And then you are going to select what angle you want to cut that solid at to create that shape. Okay, so let's say I want this shape, then this is, I'm trying to see if that's the right angle I'm going at. That looks right. When I slice that, I get the rectangle. And so it is really helpful if you go through this on your own. It'll really help you visualize those cross sections and plane sections of this figure. So all of these will be using this, is this a cube or a rectangular prism? Yeah, it's a cube. And so you have 7 different shapes you're trying to get, and you are going to select the angle and then slice it and see if you're right. So if you're wrong, like I did that on purpose, it'll tell you you're wrong and you can try again. So just keep working on that until you're successfully getting the correct answer several times in a row, and then you can restart this and we'll continue with the lesson. Okay, so let's look at question 1 in our notes. We're looking at the possible plane sections of a cube. So you just tried these on the animation, so let's see how we did. So the first one says a plane section that's parallel to the face of a cube. Well, since a cube has 6 square faces, anytime you're parallel to one of those faces, you get the same shape as the face. So you would get a square as a result. If you only intersect 3 of the faces, however many faces you intersect, that's how many sides your 2D figure will have. So if you only intersect 3 faces, you're going to get a triangle as a result. The plane section perpendicular to 2 faces of a cube. So if you go perpendicular, you can get a square, or if you go at an angle, you could get a rectangle as a result. And then if you intersect all 6 faces, remember that's how many sides your figure will have, the section, you're going to get a hexagon as a result. And so these are not the only shapes you could get. So for instance, I could intersect only 5 of the 6 faces and get a pentagon. So there are other sections that you could get. This is just a good example of those. All right, let's look at question 2 in your notes. It says you have sliced a cube into various shapes, and the shape you created depended on the angle of the plane of the slice. One shape we sliced from the cube was a hexagon, and we did that by intersecting all 6 faces. Could you slice a cube to reveal an octagon? Well, how many sides does an octagon have? It has 8 sides, right? So you would need 8 faces on a solid to create that as a section. And since a cube only has 6, then it is not possible. Since a cube has 6 faces, the largest number of sides that a plane section of a cube could have is also 6. So your answer on number 2 is no, and that is because octagons would require 8 faces on a solid. So you'd have to have a solid that has 8 faces to create an octagonal section. All right, so our next animation, also on Agile Mind, so go back to where you were doing the first part of the lesson, and you have 3 different panels down here. So notice down here at the bottom, you've got 3 different solids you're looking at. You're looking at a square pyramid, and then you have a right pentagonal prism, and then you have a cylinder. So you're going to do the same thing you did before. You have a target shape, and you have different angles that you can cut at to try to produce that shape. Okay, so again, this is great for visualizing, so go ahead and pause the video again, work through all 3 of the solids, and that'll help us answer the following questions in your notes. Okay, so one of the solids you looked at in the animation was a right pentagonal prism, a regular one, so all 5 sides are the same length. So if you do a plane section parallel to the base, which again is called a cross section, you always get the shape that the base is. And we know prisms are named by their base, so since it's a right pentagonal prism, you're going to get a regular pentagon as a result. Whatever the base is, you have the same shape. If you don't go parallel, but you still don't intersect the bases, you're still intersecting all of the lateral faces, and there's 5 of them. So you're still getting a pentagon, it's just no longer going to be regular, because your sides are going to have different lengths. If you intersect a prism and one edge, so the base of the prism and one edge, not one face, so that one edge means you're intersecting 2 of the faces of the lateral shapes there, and then one base. So you're intersecting 3 faces, which creates a triangle. If you go perpendicular to the base, then you're going to get the shape that your lateral faces are, which is a rectangle. And so there are your, sorry, it keeps kicking me out. There are your answers to number 3 in your notes. So let's look at the next puzzle, which you're now in question 4. You're looking at this square pyramid. And so remember, anytime you're parallel to the base, you get the same shape as the base. And a pyramid is named for its base. So the base of this pyramid is a square. So if you do a plane section parallel to the base, again, that's called a cross section, you're going to get a square. The closer you are to the base, the bigger the square will get. So as you get closer and closer to the apex, that square gets smaller and smaller. If you do a plane section perpendicular to the base, then when you have that section, you're going to be intersecting 4 faces, so you have a quadrilateral, but this side is going to be parallel to the bottom, but not necessarily congruent to the bottom. So you're going to get a trapezoid as a possibility. You might go through the apex, and that would create a triangle instead. So those are your 2 options. You're either going to intersect somewhere on the face and make a trapezoid, or you're going to go through the apex and get a triangle as a result. A plane section that's not intersecting the base and not parallel to it, so you're going at an angle here, you're still intersecting all 4 of the faces, but you're going at an angle, so you're not getting a square, you get a trapezoid instead. So there are the correct answers for number 4 in your notes. So our last animation is looking at the slices of a cylinder. So this is question 5 in your notes. A plane section parallel to the base, remember that's called a cross section, always has the same shape as the base, and the base of a cylinder is a circle. So you would create a circle here. If you go perpendicular to the base, so we're cutting through the top and the bottom, you create a rectangle. Remember, the lateral shape of a cylinder, if you folded it out flat, would be a rectangle as well. If you do a plane section that's not intersecting the base but not parallel to it, so you're cutting at an angle, you still get a curved shape, but it's not a perfect circle anymore. you get an oval shape. So there are your answers to question 5 on your notes. So the plane sections of a solid are interesting in math, but they also have important real-world applications as well. For instance, if you've ever had an MRI, which is standing for magnetic resonance imaging, it's a scan that you get done by a doctor, and it scans slices of your body. So, for example, here's an MRI of the brain. So they look at different slices, and that helps them make a diagnosis if necessary. You can look for brain abnormalities or different things like that, which are definitely above my intelligence. Here's a cross-section of a tree, and we know that scientists can observe a slice of a tree and see lots of information about the past. They can tell how old the tree is. It can tell weather patterns that have occurred during the life of that tree. So again, that is not something I'm an expert on, but that is really cool that they can use cross-sections to determine those things. All right, so to wrap up today, I do hope you spent time with the animations that will really help you visualize these two-dimensional slices of 3D objects. What shape is the plane section of a sphere, and does the angle of a plane section matter? Well, a sphere is a really special solid. It doesn't matter what way you cut it, you're always going to get a circle. And some circles are bigger than others. If you go through the center of the sphere, you get what's called the great circle because it's the biggest one that you can get. So some circles are smaller than others. The largest one would have to go through the center of the sphere, but they're always going to be circular sections. All right, that is it. Good luck on your homework.